Hey everyone. In our last video, we had configured a, a few BGP peerings. So as you can see here, we have AS8 and AS7 with eBGP. We have our AS16, which is our internal network. And we had 6 connected to 7, another eBGP peering. And then we had 6 with 5 iBGP and then 5 to 2 iBGP. And what we noticed was the default rule with iBGP. Now that's router 5 is not advertising its routes to 2. And that's because the default loop prevention rule in iBGP, which says if we learn a route from an iBGP neighbor, we can't advertise it to another iBGP neighbor. So what do we do? Well, in order to get around this rule, we have a couple different options. One is to just create a full mesh. So let's go ahead on R6 and let's do router BGP 16. And let's do neighbor 2.2 remote AS 16. Loopback 0. Now let's go to 2. Neighbor configure 6 exactly the same way. Okay. So now, if we take a look at show IPBGP, now we're learning the routes. So all we did here is on our drawing, we have R2, which is configured to 6 iBGP. Perfectly, good option. But this can become a problem if you have a large network with tons of BGP routers, especially tons of iBGP routers. Even here, let's say just these 6 that are all in AS16, if I want to configure a full mesh everywhere, if I want all these routers, I'm going to have to configure 1 to 2, 1 to 5, 1 to 6, 1 to 4, 1 to 3. And then 3 to 2, 3 to 5, 3 to 4, 3 to 6. And then here. So you get the point. Basically, this turns into that math problem, which is the n times n minus 1 divided by 2. That's the total number of peerings we would need. Even with a 6 router network, I'm too lazy to do all that work, to be honest. So how can we get around that? Well, what we can do is we can set what's called a route reflector. So it doesn't really matter which router we pick as our route reflector. So you could even have a dedicated box that maybe just has a ton of memory and is totally outside the data plane, but you use as your route reflector. So to show that, let's pick R3 because it's kind of out of the way, and let's have that be our route reflector for our iBGP. So what we'll do is I'll get rid of the peering from 2 to 6, and I'll also get rid of the peering from 6 to 5. And I'll do it on 5 as well. I'll pause the video and just get rid of those peerings, and then we'll start doing the route reflector configuration on 3. Okay, so what I did is I basically just turned off BGP on 2 and 5, but we could see from 6, now our only neighbor is 7. So let's go ahead and just draw that. We're learning external routes from 7 with the eBGP here. Now, let's head over to 3, and what we're going to do is let's configure all of our, in AS16, let's configure all of our routers. So 1, 2, 5, 4, and 6. Let's configure all of them to be IBGP, and we'll have 3 as the route reflector. So what we'll do is head over to 3, which again will be our route reflector. Router BGP 16. And we're going to do something a little bit different here. We're going to do a neighbor RR, what's called route reflector clients. And this is actually going to be a peer group. So neighbor RR clients peer group. Then what we'll do is neighbor RR clients. We'll do remote AS is 16. Neighbor RR clients. Update source is loopback 0. And that's it. So now what this basically did is we created a peer group, and we said any clients or any neighbors that are in this peer group will have these settings. Their remote AS is going to be 16. Their update source is going to be loopback 0. So now what we could do is just neighbor 1.1.1.1, and its peer group is RR underscore clients. And this is going to save us some configuration. It's not going to save us a ton, but it will save us some time. We don't have to do those same 2 commands on each and every. That's the local one. That's fine. 4.4.4.4. Now, you can imagine that if you had, maybe even 10 lines of BGP configuration per peer, this would be a giant pain in the neck. So show IP BGP summary. Now we can see we have all of our neighbors. Now none of them are up, but that's okay. Now what we can do is, the great thing about route reflectors is let's go ahead and I think I accidentally drew on my, hold on one moment. Sorry, I accidentally drew on my whiteboard, but okay. So the good thing about route reflector clients is that they all just need the same configuration. So it's going to be router, I don't know why I said OSP, we have BGP 16. They're going to do a neighbor of 3.3.3.3. Remote AS is 16. And neighbor 3.3.3.3. Update source is loopback 0. So you'll notice there's nothing in this configuration from the client side that specifies that 3 is a route reflector. The only route reflector configuration is here, and actually on 3 I realized I forgot to do it. So let's go into 3 and let's do router BGP 16. I forgot to say that neighbor RR underscore clients is actually a route reflector client. So let's do show run section router BGP. So we assigned our peer group. The peer group is remote AS16, update source loopback 0, and they're all route reflector clients. And then each neighbor, we just have to say that they're in the peer group. So a much smaller configuration than if we configured all 3 of these on each neighbor. So now I could take this config here, and I could just go to all the clients and start pasting it in. Don't need to do 3, 4, 5, and 6. So let's head back here, show IP BGP summary. And all of our clients are up. And notice that we're learning 2 prefixes from 6. So we should be learning about R7's loopback. So let's take a look and show IP BGP. and we are learning about the loopback. We don't have it best. I think I may have taken off the next hop self configuration. So let me go to 6 and show run section router BGP. Yeah, I did. So let's go ahead and do conf t router BGP 16. Next hop self. Okay. Now, all right, that'll update in a moment. But let's go to some of the other clients and let's see what their BGP tables look like. Show IP BGP. And sure enough, we are learning some routes from, so R2, show IP BGP, 4, show IP BGP. There we go. How come 1 and 2? Oh, there we go. Okay. I realized that we weren't learning it. BGP is slow. So here's 7. The next hop is 6.6.6.6, which means it's going to be in the routing table. 2. If we go to 4, we're learning it. If we go to 5, show IP BGP. So instead of configuring a full mesh everywhere, now we have R3 being the route reflector, and it's learning about all the routes. Now, one of the cool things about the route reflector is that it's not in the data plane. So, for example, let's take R5, and R5 would like to get to R7's loopback. Now, I don't believe on R7's point of view I'm actually learning anything. Show IP BGP. No. So what I'm going to do is I'm going to go ahead and on R6, I'm just going to be sloppy and router BGP 16. I'm just going to go ahead and redistribute OSPF 1. We'll just go ahead and do some redistribution. Okay, so now we're learning it. So now 6 knows how to get to 5, and knows how to get to 4's loopback, etc. So let's say from R5's point of view, R5 is not a directly connected neighbor with 6. It's only a neighbor with 3. Okay? But when it sends the traffic, we don't want the traffic to have to go to 5 and then to 4 to 6 to 7. We want the traffic to go directly to 6 and out to 7. Which, using the next hop value, this is what's going to happen. So if we do show IP BGP again, we can see that from 7, the next hop is 6. So let's trace source loopback 0, and sure enough, we could see it just goes from 6 to 7. So even though all these routers are peering with the route reflector doesn't actually have to be in the data plane. It's strictly just a control plane. The data plane just goes directly from 5 to 7. And we could do the same thing from 2. Let's trace 7777, source loopback 0. In this case, we have some load balancing. So it either goes to 5 or to 4. Either way, it ends up at 6 at the next hop. It goes to 7. But regardless, it never goes to 3. So this is how we can get around, or not how we get around, how we solve the problem of IBGP's loop prevention. And we could do a full mesh, or we could do a route reflector. So I hope you guys enjoyed the video, and we'll see you on the next one.